Welcome to the channel Tribe. In this session of TTTribeCast webinar, we are having Gayathri Mohan discussing on continuous testing strategy for CFRs. Huge shout out to BrowserStack, our exclusive sponsor for all community events and premier sponsor for conferences. We thank them for supporting this event.
So I welcome all of you to this webinar by Gayathri Mohan on continuous testing strategy for cross-functional requirements. Now I would like to call on stage Gayathri. Gayathri, to say a little bit about her, she joined ThoughtWorks after her college as a quality analyst in 2008. And since then, she has worked into multiple domains, travel, retail, banking, and in a lot of range of technologies like mobile, IoT, machine learning, SaaS, and more. She is author of book on O'Reilly full stack testing that was just recently launched, and she has also co-authored the ebook perspectives of agile software testing. So with that introduction, I would like to call Gayatri on the stage to take over and take the webinar on continuous testing strategy of for cross-functional requirements. Yes, Gayatri. You can
Thanks,
share.
Vanshika. Thanks for the introduction, and hello everyone. Really happy to see a lot of folks being present here. Let me share my screen and begin the talk. Once again, I think happy to be here. I was really looking forward to the talk and getting to know the community of testers that is part of these events regularly. I mean, having that enthusiasm to join on a Saturday is evidence of how keen about you all are about learning something, and big kudos to that. So, coming to the topic of today, continuous testing strategy for cross-functional requirements. So there are a couple of heavyweight items there, like continuous testing and cross-functional requirements. We'll get into the depth of what those terms really mean, and for those who are new to those terms in the course of the talk. Short introduction, I think Vanshika had already spoken about me. So a bit more about me is currently I'm sitting in the UK. I'm principal quality analyst with ThoughtWorks. Have been a member of Tech Advisory Board in ThoughtWorks India, and also played multiple roles like Global QA SME for ThoughtWorks Capabilities, Office Tech Principal for ThoughtWorks Chennai office. So that's about me, and recently I got a great opportunity to author a book, and whatever concepts that we are going to discuss today is also part of the book, and I'm happy to actually present some of them as part of this talk today. So we'll be covering these items. The flow will be having an introduction to cross-functional requirements, introduction to continuous testing as a concept, and we'll put those together to form the continuous testing strategy for cross-functional requirements. And we'll take a couple of examples like security and accessibility, which are cross-functional requirements, and apply the strategy to understand the strategy a bit better. So starting off with introduction to cross-functional requirements. So we'll take an example of a 3-tier e-commerce web application. So when we say e-commerce application, something like an Amazon or Flipkart, whatever, for simplicity and for sake of understanding, let's just say that we have just 3 layers. One is the UI layer, and then there are the services layer, and then there is a centralized database. And to give a bit more information, let's just say that there is an identity and access management service, which does the authentication and authorization part. And then there is the order service, which manages the orders from the UI, like creating an order, updating an order, deleting an order, all those sorts of stuff. And then there is a payment service which manages the capture, refund, and cancelling of payments. So when we think of such an application, immediately if we have to jump into the list of requirements and how do we go about building these capabilities in the application, I think we'll quickly will be able to capture the functional requirements, and we'll soon enough have a bunch of these functional requirements gathered. For example, we'll know that user should be able to log in and browse the product catalog. User should be able to purchase an item and get it delivered. User should be able to manage their orders. I mean, these are very typical functional requirements that will satisfy the existence of the e-commerce application itself. Um, these are just examples, but I'm sure it is easy to capture all of these functional requirements if we talk to the SMEs, and this is something that the team is very comfortable with. So now let's say, so we have finally chosen a product on the e-commerce application, and it took more than 2 minutes to add the product to the shopping cart. Right? Functionally, you were able to add the product to the shopping cart, but it took 2 minutes to add the product to the shopping cart. Or let's say we were able to make a payment with our card successfully after completing all the functional requirements, but the card details are open on the internet next day. Will we continue to use that application? No, right? It's not really usable. Nobody wants to have such a bad experience with the application, even though it was functionally working, right? We were able to add a cart and make a payment, so functionally it was working. Still, we wouldn't use the application. So that's where CFRs, or the cross-functional requirements, come into play, where the cross-functional requirement will be if any action happens on the application, it should be completed within X seconds, right? Like it will be like you should be able to add a product within 10 seconds or 2 seconds. And that is something that applies to actions across the application, not just on the shopping cart, but any action that you make on the application, you should be able to see a response within X seconds. And that's when you'll be able to satisfy your customer. And another aspect is you should be able to transmit and store the personal details of the user securely. Otherwise, nobody is going to get back to your application, or you will also be facing some sort of legal issues later on, because the personal information has to be secure without any question. So these will be the CFR for the relevant problem statements that we spoke about. And it doesn't stop there. We'll come to a list of cross-functional requirements in a bit. So that, given that introduction of examples, we can actually say that this can be broadly a definition for cross-functional requirements, right? Cross-functional requirements refer to those features of an application that have to be built into every functional feature. So there was a functional feature to add to shopping cart, and there was a functional feature to add to payment. And cross-functional requirements doesn't stop with one particular functional feature, but it has to be built into every functional feature. That's why it's called cross-functional requirements. For example, the security is not something that you build only when you're paying your credit card information, but it's also about handling the user's personal details. And similarly, the response time is something that is across the application. So because it is so broad, the list of cross-functional requirements, we can actually try to visualize it into two broad buckets. One is executional qualities and the evolutionary qualities. So cross-functional requirements typically try to gather the executional qualities in terms of availability of the application, authentication related requirements, monitoring, security, which are qualities of the application during executional time. And evolutionary quality, something which is like maintainability, scalability, extensibility, right? Like, so as the application grows and scales into scales beyond the core functionality and cross-border uh, needs, cross-functional requirements once again try to establish those qualities for the application. So these are very essential for the business to survive, basically. So you can actually deliver the very core functional requirement of delivering the product, but if we are not actually happy with the executional qualities, the customer will be very unhappy. And if we are not focusing on evolutionary qualities, mainly the software development team will be affected because there's no maintainability, we can't extend quickly, and also the business will be hit because scalability is not catered to, and eventually your customer will be unhappy as well. So what are some of these critical CFRs? So these are like a lot of uh, lities, like you can see there's auditability, recoverability, portability. There are a lot of lities here, and this is just some of the critical ones. I wanted to emphasize on that. There are a lot more than this. So if you see building evolutionary architecture book lists more than 30 plus CFRs, um, and there are a lot more to it. And people use different flavors to the same CFRs as well. But the crux of it is understanding what it means to our application that we are building. So I think it is essential to call out the difference between cross-functional and non-functional requirements, because people are usually accustomed to hearing the term non-functional requirements, and um, why do we prefer to say cross-functional requirements rather than non-functional requirements is because the requirements are actually spread across the application and need to be built and tested as part of every feature. So the name itself is something. If you say non-functional requirement, it feels like you can actually put it at the back of the backlog, and the priority wise it takes a back seat. And I've seen a lot of clients where non-functional requirements are not captured until a very late stage, but you can't actually build the non-functional requirements at the end, but it has to be built in right from the beginning, within each functionality, within each story, to make the application cater to those requirements, right? So that's the name. That's why it is called as cross-functional requirements, and at least some of us prefer to call it cross-functional requirements and non-functional requirements. Some more information on the term cross-functional requirements is that Sara Tarapovilla, she introduced the term. You can actually look for her blog on her reasoning on what she thought of when she introduced the term. And folks like Sam Newman, who wrote the Building Microservices, continue to use the term cross-functional requirements as well. And I prefer to call them cross-functional requirements as well, mainly because it emphasizes that it needs to be built into every single user story and every single feature, and it's not an optional stuff to park it at the end. So let's move on to introducing continuous testing. So this is for, once again, I think these are basic introductions for folks who are new to these terms. Um, continuous testing. Continuous testing. I came across this term in one of the Jess Humble's books. I think it was continuous delivery. So he defines this as a capability where you're able to continuously test the application using both manual and automated testing methods for every incremental change, and being able to alert the team on what changes cause what deviation. Um, and that gives an opportunity for the team to fix any kind of deviation at a very early stage. So suppose, let's say that your performance is broken at a very late stage, like just you're going to go live and there is you do a performance testing just 1 week before your release, and you find out there's a major performance issue that needs some architecture level changes. You are actually delaying the release, and you're also, or you are working late hours to fix such issues, which both of which are not intended outcomes. So continuous testing is a method where you are able to continuously test for various functional and cross-functional requirements using both manual and automated testing methods to give that feedback continuously to your team. So there are several process related stuff as well that comes into picture in continuous testing. So for example, shift left testing processes where testing can start as early as verifying the design prototypes, being able to add linters and uniters, and being able to run them on the developer machine and get the feedback as early as possible. Um, and then actually doing some dev box testing, functional acceptance criteria being run as smoke tests, also cross-functional requirements run as smoke tests, and continued by manual exploratory testing. So, manual exploratory testing is a phase that I wanted to highlight specifically because manual exploratory testing is a phase where you can actually explore for both functional and cross functional requirements. So, that is a very key part. And if we just focus on just a set of requirements that come in as user stories, that doesn't solve the intent of continuous testing, but your skill to go and explore around all the edge cases and figure out what are the functional and cross functional um, edge cases will make sure the continuous testing process is complete. So, why do we do all of these things? Because it helps us to be able to do continuous delivery. So, continuous delivery is the capability to be production ready at any given point in time, so that the business can actually reap the benefit of building such a software. So early time to market, you're able to test whether your product is actually meeting the customer requirements and get the feedback on real time, and then actually be able to incorporate some of the new features in a very quicker cycles. So that's the value of doing such a rigorous process of continuous testing, following those practices, following those tools and all of those things. So, understanding the value out of continuous testing, both functional and cross functional requirements, is not only enough for the team, but sometimes we also have to educate the business folks to invest in such kind of testing methodologies, to make them understand that they'll be able to do continuous delivery if they are in a place that is where the code is production ready all the time. So um, that's some overview on continuous testing, and some more benefits that reaps that I've seen are. So first of all, it helps in achieving common quality goals. So when the team knows that these sort of requirements are added into your pipeline itself, then they know that if okay, I need to make sure that the performance is within X seconds for every check-in that I make. So that's a common quality goal that everybody will start working towards. and it will be like continuously worked upon, and the awareness has prevailed. And early defect detection, because for every small change you are getting the feedback and the opportunity to fix it. There is enhanced collaboration. Basically, we once we establish the common quality goals, people actually know that we have to collaborate to achieve those things. Combined delivery ownership, there's no pointing fingers saying that that particular person did this, and so the performance went down, or so the security went down. But for every incremental change, you know that we have to achieve the quality goals, and there is an ownership of combinedly delivering capability to deliver on demand. As we spoke about the continuous delivery possibility, right? Like for the team to be able to deliver it continuously and achieve the four key metrics for a high performance team. Four key metrics is another industry standard that many teams are actually trying to adopt to. um, it tries to establish how the team is performing, how the software team is performing in terms of four uh, different angles. Will not go into that in detail, but the continuous testing process helps in achieving the goals of the 4K metrics as well. So, continuous testing strategy for CFRs. Now that we have had the introduction for continuous testing and also for cross-functional requirements, what can be a strategy for cross-functional continuous testing the cross-functional requirements? Why? So, at this juncture, right? I mean, why do we need a specific strategy for cross-functional requirements? I wanted to address that point. Um, so if we see functional requirements, I think we are very, very comfortable with addressing the continuous testing of functional requirements. Like we know that we need to write unit tests, then we need to write integration tests, and I think most of us even contribute to functional automation, right? We write services tests, we write end-to-end UI tests. So those are well established processes. But when it comes to cross-functional requirements, I think it is mostly very vague. And sometimes the approach to continuous testing them is left out, mainly because it does not actually directly attach itself to a particular testing methodology or testing tool. So, this particular section, I wanted to give that learning of how can we attach the different testing techniques that are available to test some of the cross-functional requirements, and what are the tools that can be adopted to continuous test the cross-functional requirements. That will be what we'll be talking about as part of the strategy. So, just because that we have a lot of cross-functional requirements, right? Like we need to have a approach to um, assimilating them in our mindset. So earlier we saw that they cater to two broad buckets, which is like they cater to for execution and evolutionary qualities. And now if we have to further deep dive and have a much more clearer picture, we can adopt the first model. So all the cross-functional requirements will typically fall under these um, five buckets. Let's call it five buckets. The first model is nothing but an acronym which stands for functionality, usability, reliability, performance, and supportability. And if you see functionality, it is a category of requirements that can be realized as user flows. So, if we have to take, for example, authentication, which is a cross-functional requirement, it can be realized as a user flow, right? Like you'll be able to log in. You can have multi-factor authentication, and if you see accessibility for that matter, that's also something that you can realize as user flows, which is once again a cross-functional requirement. And usability, it's a category of requirement that affects the user experience. So user experience in the sense like how it is actually visually appealing. One is that, um, how is the design for that matter? Is it really usable? Like we were saying, does it take 10 clicks to finish an operation where it could have actually listed everything on the first page? So those kind of user experience related cross-functional requirements. And reliability, once again, I think there are a bunch of cross-functional requirements that can be grouped in under reliability. Basically, these sort of requirements make the application fault tolerant. Like we'll get into those details of it, but if you see, there is you need to actually have backups, archivals, and all of those things. It will make it a fault tolerant application. Performance, I think it is very obvious. One, which is we understand front and back and all of performance KPIs like availability, throughput, um, and then supportability. These are specifically talking about the evolutionary code qualities like maintainability, testability, secure code, those kind of evolutionary code qualities that we spoke about. So this is to actually begin with our testing approach. Once again, we are adopting this model because there are a lot of cross-functional requirements that I spoke about in the previous slides, and to actually have a visual understanding of how to apply some of the existing testing techniques and tools is why we are talking about a model here. So, adopting that FERPS model, now the testing techniques that can be applied for the CFRs that fall under those buckets. So for functionality, I think it is something that is I've spoken about is manual exploratory testing is very important. That is one testing technique. Functional test automation includes the bucket of unit integration services, end to end, like the entire functional test automation testing techniques. There's data testing techniques that have come into picture, like you have the like DQ, Kafka related testing methodologies that will come into picture. Usability, I think we spoke about the visual experience, the user experience related stuff. And there's also accessibility testing techniques that are available right now. In the next slide, we'll be talking about the testing tools that can be used for each of these things. So that will give a much further clearer picture on these testing techniques itself. And then the reliability part can be tested by stress testing, chaos engineering, infrastructure testing methods, right? Like the infrastructure is one of the backbone of our application, and to make the application fault tolerant, infrastructure part has to be tested. And some of the testing techniques that are available, testing tools that are available for infrastructure, something that we'll talk about in the next slide as well. Performance, back-end performance, front-end performance. And supportability part, I think the evolutionary code qualities that we have been talking about. I think there are architectural fitness tests, which make sure that the maintainability part is maintained. Some of the CFRs like maintainability, supportability, extendability, or some can be actually automated and included into your continuous testing pipelines. Static code analyzer have always existed, which gives us the critical feedback of the code quality itself. It also, there are other things like it gives the maintain. It also contributes to maintainability of the code part. Um, Dynamic code analyzers have existed to support various cross-functional requirements, linters for that matter. So broadly, if we have to approach cross-functional requirements, continuous testing, these are the testing techniques that are available for us. And while we go inside each one of them and look into the tools, it might actually give a clearer picture. Um, some of the tools, the testing tools part was like we know that manual exploratory testing. I think for functionality, I think these are some of the things that we'll be very familiar with. Whoever comes from the functional background, Like you have Postman, browsers, Workman. I don't think many of us need introductions to that. Functional test automation, as I was saying, unit, all those, the services, end-to-end tests, contract tests, all of those things for help us do that. Data testing part, I think, test containers, DQ, great expectations, all of those things are helping us to do the continuous testing part. And these tests can be added to the continuous testing pipeline as well, like the CI/CD pipeline as well. When we come to usability, I think visual testing has been, it's very well adopted right now. Some of the tools that help us do is Backstop.js, Cypress, Happy Tools, etc. User experience testing, I think there are A/B testing tools, prototype testing tools like User Zoom, Optimal, Workshop, and accessibility testing tools. I think once again a widely adopted set of tools that are given there, Lighthouse, Wave. So when we come to reliability, I think we talked about stress testing, making sure that we are giving enough stress to the application and seeing if it can handle that stress, and be incorporate that fault tolerant mechanisms when there is stress. So some of the performance testing tools that are that are available can be utilized to for stress testing as well. And chaos engineering is another engineering practice that has come into picture. We Where it makes sure that you unveil some of the unknowns. There is a set of process practices that comes under chaos engineering. But the tool wise, I think Chaos Toolkit, Chaos Monkey, some very different tools are available to make sure that we are able to actually unveil some of those aspects that will give stability for the application and make it fault tolerant. That was reliability for us. Infrastructure testing, TFLint, like there are a set of tools that you can adopt to make sure that the infrastructure is pinned up with the requirements that we initially asked for, and it's scalable, then it is compliant. Back-end performance testing and front-end performance testing, these are well-established tools that are available. Supportability, I think we spoke about architecture fitness tests. So the JDepend, ArcUnit, NetArc test are some of the tests that were some of the tools that can be used to make sure that for example, that if a certain module shouldn't be actually depending on other modules, like it shouldn't actually have any dependency on other modules, and it should be a independent package so that it can be reused across the application, then these kind of tests can be added that will actually scan for any kind of dependencies. So if there are and that will indicate whether the package is independent or not for reusability and extendability purposes. So these tools actually try to see if there is no cyclic dependencies among packages. It is just dependent on certain expected ones. So just to maintain the sanity of the architecture which was initially planned. Once again, if we remember, supportability is a class of requirements that comes under evolutionary qualities. Like evolutionary qualities are like the maintainability, scalability, extendability of the code, readability, testability, and all of those aspects. And some of them can be addressed via these architecture witness tests. Static code analyzer, I think we know many of them exist. Some, to give an example, is checkstyle, which makes sure that the readability or maintainability of the code. SonarQube is code quality, and OWASP has a lot of static code analyzers, which gives feedback on security aspects as early as possible. Once again, dynamic code analyzers, Zapdash is an example, which does active injection of security bugs into the system and making sure that the dynamically the code is actually attacked and the vulnerabilities are opened up. PA test is another mutation testing tool, which is another way to make sure that we are able to cover the right tests in the unit test level. And linters have existed for a long time, and some of the linters examples are ESLint, unsupported browsers. So these can actually help us even do cross-browser compatibility testing. So these linters can hint whether the feature that we are using to build that particular functionality is compatible with all the chosen browsers that is needed for the application. So this is like we have covered broadly all the testing techniques and also the testing tools that can be helpful for achieving continuous testing of cross-functional requirements. And to this will be the takeaway for the next section, where we'll apply those things, that model, the tools and the techniques for one particular CFR like a security, and see how we can visualize the continuous testing process for security. So when we take security for that matter, I think security exhibits itself in these three angles, right? Like security can be broken down to be visualized in these three angles. So it can be functionality, where you can have um, functionality in sense it can be realized through user flows, right? You can have multi-factor authentications, or you can have um, the services that are actually being authenticated before calling. So once you are accessing for a particular service, you are actually authenticating the user's authorization part, all of those. So security exhibits in a functional manner. Even for that matter, I think if you are dealing with the bank application, not everybody can view your account details, right? Only you can view your account details, and probably the bank employees are authorized to view some details of your account, but not the others. Those are like some of the security functional security related requirements that exhibit themselves as functional flows. And then the security related requirements that exhibit themselves in the reliability format. So when there are potential threats, how do we react to them so that we can make the application fault tolerant, right? Um, and there is a supportability part where the code should be checked for known vulnerabilities. So this will give us a picture on how to approach continuous testing of security itself. So security, if we have to go, this is a very security is a widely it has become very widely adopted right now. But if we have to take really vague ones, this is giving an idea of how can we break them down and visualize into this framework, so that the techniques and the tools can be adopted and put them together, and we can put a strategy together for that particular CFR. So if we have to do that for security, right, like adopting some of the testing techniques and the tools, this was how continuous testing for security could look like. So we will have some kind of static code analysis during development, like snake OS dependency check, and some pre-commit hooks like Talisman. This will help during development phase. And in CI, I think we can have SAS, once again, static code analyzer tools. There can be functional automated tests. There's a image vulnerability scanning for the infrastructure part. There are DAS tests that we can adopt. And then, as I keep emphasizing, manual exploratory testing is a very critical phase for continuous testing. So a lot of security related scenarios or cases can be tested during manual exploratory testing itself. and there's release level pen testing, and there are RASP tools in production that will actually help us build that reliability factor as well. So they will actually monitor what are the kinds of requests that are coming in. If there are odd requests that are coming in, it will learn and it will actually prevent those requests from getting successful. So this will actually tell us that how the tools can be put together to form a continuous testing strategy for a CFR. We can do the same thing for another CFR, which is accessibility, and then and that should give further evidence on the strategy and on the approach that we are trying to apply. Once again, I think when we think of accessibility, I think it can see we can see that it manifests into these three buckets. Like there's functionality, which is like functional force to support accessibility, right? Like, so there needs to be a transcript for every video. That's an accessibility requirement. And there's a usability factor, like all users with disability should be able to use the application. So it's just not only the users. I mean, usability doesn't stop with people who are able to use the application normally, but also for people with disability. Like they should be able to use it with screen readers. They should be able to use with switches. So those kind of usability related stuff comes into picture for accessibility. And then there's supportability part where the code and the evolutionary qualities needs to be validated. Like for accessibility, we need to make sure that the code has the accessibility tags, the required alt text and all of those things built into the code to make sure that the screen reader can actually uh, read the code, read the application as it is intended to be served for the user with disability. So for these three angles, I think once again, if we have to put together the continuous testing strategy, like we have during the design and validation phase, we can actually um, the accessibility is one area where you can even start from the design phase, that is like validation of the design with the angle of whether, like for example, like I was talking, the transcripts needs to be there as part of the video section. That is a design part. Like you need to make sure that your design of the application is catering to accessibility. Like you need to have a simple navigation system. You need to have a consistent navigation system. Like if you're actually having menus, then it has to be consistent across all the pages. So some of those things are design related stuff that will cater to accessibility, and making sure that the design is appropriate is a crucial step. And during development, once again, I think we have static code analyzers, we have runtime checkers. Those testing techniques can be adopted here, which are relevant to accessibility. And then once again in CA, you can have functional tests as well for accessibility related stuff. And there are runtime checkers that we spoke about. And manual testing is once again very key, and especially with screen readers and keyboard functional flow. And release testing with actual assistive devices is going to be helpful to understand if we are catering to all the assistive devices. So that's the full that's the part of the um, that's the part that I wanted to conclude with, saying that we have approaches that can be adopted to enable continuous testing for cross-functional requirements, and it is no more um, a very vague term, and we should be able to incorporate that into our testing strategy. And whatever we spoke about is further elaborated in the book. I mean, I just leave it at that. So summary, CFRs define the executional and evolutionary qualities of an application. I think we need to understand why CFRs are important and make sure our business stakeholders also understand why CFRs are important. Now, it starts from there. From whatever client experience that I've had, it is very easy to miss out on the cross-functional requirements. And if we have to attack it at a very later stage, it's really tough to do that. And cross-functional requirements are as essential as functional requirements for the application success. Um, Together, functional and cross-functional requirements make the application a high-quality product. Cross-functional requirements can be visualized along the FERBs theme. Like all the cross-functional requirements can be visualized to manifest within the 5 buckets that we spoke about in the FERBs theme. So any term that you hear called as cross-functional requirements, the first step will be to see how it manifests itself into these buckets, and then you'll have an idea of how to approach the testing for that particular bucket. So that will make it easier for us to break down such complex cross-functional requirements and be able to provide a testing strategy for that. So I think we have spoken about it. There are techniques and tools that we can adopt, and therefore continuous testing is as much as feasible as functional requirements, and should be included in the testing strategy. So that's the end of the presentation. So I thank you very much.
Thank you, Gayatri. We have some questions, so I think we can take those now. So we have Megha who is asking, could you please let me know what is archivability?
Archivability, I think, archivability is the term which says that we should be able to. So there are different ways in which I can explain archivability. Like currently, I'm working in a client where there is a regulatory requirement that the history of transaction that has been made on that particular client has to be maintained for 6 years. So you need to archive all of those transactions to meet some of the regulatory requirements itself, and there are also functionalities that depend upon the history of all the transactions that have happened for a particular client. So being able to archive all of these particular relevant transaction in a way that you can pull back the information um, in a comfortable manner for the application. So for example, it could be for bill generation or reports creation. You are actually tracking all of the transaction for a month, and you're archiving it for something, and you're creating some report for your user. So that could be one use case for archivability. You could also look back and see how you have spent. That is also another use case of archivability.
Understood. I think that answers your question, Megha. We have another question from Gandharv, QA engineer STG. The question is, may you please share your thoughts more about architecture fitness tests? Is there any criteria for fitness tests?
So, so this is such a broad area, and I think Building Evolutionary Architecture is one of the books that covers elaborately on fitness test part of it. So, as I was giving one example, right? Like, let's just say that um, when there is a small team, we know everything that what are the, like, just say like few developers who sit on the across the table, you know exactly what you're building. So you know that for example, the order management service should be independent. You know that all the order creation, order updation, order deletion stuff should go inside order management service. And tomorrow, if there is going to be a mobile app for the e-commerce application, you know that you can reutilize the order management service to cater to the mobile application as well. And so it needs to be an independent package. Um, but when there are big teams, right? Like when there are really big teams, and what could happen is people might actually override the package being independent factor, that makes it reusable. Like it is catering to reusability as a CFR, right? So for when it is a small team, you know that reusability is a critical CFR, and you're actually making sure that the order management service is reusable by making it an independent component. But when there are large team, it is very difficult to make sure that reusability is a very important CFR, and hence you have to keep your components independent, and you should not have cyclic dependencies between components. How do you enforce this kind of a thought process? Like, as I said, if it is a functional requirement and it is orchestrated between multiple teams of then it is possible to write a smoke test. Like, for example, one team is dealing with order service, one team is dealing with payment service, and one team is dealing with IAM service. Then it is possible to just deploy all the services into an end-to-end environment and write the smoke test to make sure that the all the three services are acting together to be able to deliver the functional value. But for the reusability part, how do we ensure that it happens? How do we ensure that they are still kept in a place where it is independent and it is easily plugged out and pluggable and into other places? So that will be the use case, and that will be one example where these kind of architecture tests will be very helpful to manage the initial thought process of why that component is made uh, abstracted in a certain way.
Understood, understood. I think that answers your question, Gandharv, and you can probably read more on that from the example that Gayatri has given. The next question, the last question we have is from Hitesh. Hitesh is asking, can you please share some info on how to implement performance testing early in SDLC stages?
Sure. So, I think I've spoken about this in my book as well, very elaborately, because performance is one thing I feel like it's most critical, but at the same time, we don't actually do it as early, but do it only at the later stages. Some things that can be very easy, and you can also strategize it, is like adding some pick up some of the critical endpoints, like critical APIs that needs to be like, for example, let's just say that searching for product, right, in a e-commerce application on a Black Friday or some kind of a high volume scenario, it's going to be hit more than once. I mean, it's going to be used more than any other APIs. If you see that kind of a critical need for that particular API, then making sure that we add up a performance test with the response time and the expected load for that particular API, at least as part of your smoke test or as part of your regression test, will ensure that you get that feedback as early as possible for every commit. Or you can even strategize it at least to do that, at the like in a nightly regression way, based on how comfortable is your business with providing that kind of environment or that kind of cost and all of those things. I think as QAs, we need to influence in getting those things, and there is no other way that I look at in sacrificing those. And I mean, that's a part still I think business needs to understand, and there's a possibility they might say no. But as simple as actually validating the response time on a predicted load will be something that we can do as early as the CI CD pipelines for every commit.
Understood. Thank you, Gayatri, for that answer. I think that brings us to the end of our session. Thank you so much, Gayatri, for being a part of this session and also joining in so early. It's early there in your place. So thank you for joining in. There are a lot of your book readers here also, and I can see that they are reading the book and they are loving it. So thank you for sharing your insights with us. A huge shout out to Browser Stack, our exclusive sponsor for all community events and our premier sponsor for the conferences. We thank them a lot for their support in conducting all of these events. Thank you to all the attendees for joining in today. We know that joining in on a weekend is a bit difficult or tricky, but you joined in and uh, you had that initiative to learn something on a weekend. That's great. So big thank you for joining in. Hopefully we'll meet you again in another session, and we learn more in those sessions. So thank you. Bye and happy weekend.
Thank you, everyone. Thanks for joining and have a great weekend. Nice meeting.